Alright, for this next video, we are going to solve quadratic inequalities algebraically. Yesterday, or the last lesson, we were solving by using graphing. Today we're working on solving them algebraically. Now, what we're going to do is our steps. 1, we are going to solve, and you're seeing all sorts of these related. Solve the related, it's not going to be inequality. We're going to solve the related quadratic equation. Step 2, we're going to plot the solutions It might be one solution, it may be no solutions, or it may be 2 solutions. We're going to plot the solutions on a number line. Okay. Step 3, we're going to test values from each interval. We'll see what that means when we're doing an example on the number line. To see if it satisfies the inequality. Step 4, we'll write our solution set from there. Okay, after we've tested stuff. Okay, so example 1. Okay, let's solve x squared plus 5x is less than -6. Okay. We're going to first solve the related equation. We're going to solve x squared plus 5x equals -6. Now, if I'm going to solve this, I'm going to get all the terms on one side and 0 on the other. So x squared plus 5x plus 6 equals 0. Okay. This will actually factor. I'm going to use factoring here. You can use quadratic formula, but I know 2 numbers that will multiply to 6 and add to 5. And that'd be 2 times 3 and 2 plus 3. So x plus 2 times x plus 3 is equal to 0. X plus 2, sorry. We're going to use the 0 product property. X plus 2 equals 0, or x plus 3 equals 0. So x, I'm going to subtract 2 from both sides. I'm getting a little ahead of myself here, sorry. X equals -2. I'll subtract 3 from both sides here. Or x equals -3. X equals -2 or x equals -3. So what do we do now? We we plot the solutions on a number line. So I'm gonna go, I got -2 and -3, so I'll start at -5, -4, -3, -2, -1, 0, 1, and so on. I'll put 2 down, makes it look better. Okay, on my number line, now this is just less than, I'm going to put an open circle at -3 and an open circle at -2 because it is less than. If it were less than or equal to, I would fill those circles in. Now, I'm going to test -4. So I'm going to test things over here. I don't mean to shade that. Just to see if that's true. So I'm going to plug -4 squared plus 5 times -4 and see if that's less than -6. Well, that's 16, and that's -20. That's less than -6. I got -4 is less than -6, and -4 is not less than -6. -4 is bigger than -6. So this is false. Okay, this is not part of the solution. Let's look between -3 and -2. So the next point I will test is -2.5. -2.5 squared. I'm putting it into the original inequality. Plus 5 times -2.5 is less than -6. Well, -2.5 squared is 6.25. And 5 times -2.5 is -12.5. And is that less than -6? Well, 6.25 and -12.5 is -6.25. Less than -6. That is true. So that point is true right there. It means every point in between these zeros is true. Okay? Now, I am going to test. So I've tested to the left of -3, tested between -3 and -2. I'm going to test to the right of -2. So I'm going to test, and 0 is always a good one to use. And I got 0 squared plus 5 times 0 is less than -6. And this is 0 plus 0, which is that less than -6? It is not. That one's false. Like that one was. I didn't write that down. So it's false over here. It's only true between these two values. So here's how I'm going to write the solution. X is less than -2 and greater than -3. That is the solution to that. If you could see that. It just occurred to me. You may not have seen what I was writing there. But we'll just stop at that example for now. All right, guys, take care. I'll see ya.